Hello. So in this episode, we're going to go ahead and attack this final paragraph of our difficult age word problem here. But just to sort of recap where we've come so far, first video we looked at this first paragraph and we reduced it to this equation, which of course is not quite simplified yet. Second video we looked at the second paragraph here and found an equation for it. And finally, in this video, we're going to look at this third paragraph, which it gets quite involved. There's quite a bit going on here. So what I'm going to do is I'm going to take this one a bit faster. In the previous two videos, we stepped through pretty slowly on how to get these different equations here and here. But on this last video, or for the third paragraph at least, I'm gonna breeze through it a little faster. So you may find yourself wanting to pause the video to look carefully at the step. Without further ado, let's go ahead and tackle this third paragraph, and let's move it up here. And we're going to go ahead and start from the top, from the upper left, when Tim was 1 year old. Now, I made a mistake when I first looked at this. I just thought, okay, t equals 1. But that's not really how you look at this. It says when Tim was 1 year old, that there's a when involved, and this when right here is going to be an x value, which is going to represent time. So we're going to say t plus x sub 1 equals 1. And I'm going to use this sub 1 here because there's a lot of different whens here. We've got Mary was here when Tim will be when. We got a when here. 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 When here. And guess what? These are all different whens. That's what makes this problem really difficult, is because we've got a bunch of different whens. So we got one up here, 2, 3, 4, 5, 6 different whens that we're going to deal with. That's going to mean we're going to have 6 different x values. So this is going to be x sub 1. Down here will be x sub 2, x sub 3, x sub 4, x sub 5, x sub 6. So we're going to need to get equations involving all of these time values, and then at the end we're going to crank out some algebra to go back and give you an actual equation. So it's going to get someone involved here, but we're just going to eat this elephant one bite at a time, like we said in the first video. We're going to take it one step at a time, and we'll crank through this. So this is going to be our first equation here. T plus x sub 1 equals 1. And I'm going to leave this x sub 1 in red because I'm just going to color all these whens different colors just to highlight all these x variables that we're going to want to solve for. So next section here, Mary was 3 years older than Tim will be when. So we got a new when here, and this is going to be our x sub 2. So we're going to translate this into the equation down here. So we got this the left-hand side of the equation has Mary, but we also are referencing back to this when over here. So when Tim was old, Mary was. So this is the same time value corresponding to Tim being 1 year old corresponds to Mary here. So that's where we get this m plus x sub 1. It's Mary plus whatever this time difference is. And now she's going to be 3 years older than, which is going to be our 3 plus here. Tim will be when. So again, this when here is going to correspond down to this x sub 2. And so Tim will be when is just Tim's current age plus x2, whatever this when is, this other when. Okay, so that's our second equation. And moving on, we'll go ahead and turn that blue and move on to our next line here. Jane is 3 times as old as Mary was 6 years before the time when. So now we got 2 different whens here. We got when Jane, which is going to be our left side of the equation here. J plus x sub 2. That's going to be when Jane is 3 times as old. Well, that's just going to be our 3 here. Mary was 6 years before the time when. Now this one is a bit of a brain cruncher because you got 6 years before is a little bit different than what we've been used to in the past. So all that means is we're going to subtract 6 years from this Mary when time. So as old as Mary was when is this m plus 6, 3, and 6 years before is going to be this minus 6 part. So again, it's a little tricky. You may need to slow this down and think through it a little bit. This might be the trickiest part of this problem. The rest of it is just kind of cranking through it. So we're going to turn this x3 is going to be green, and we're going to reference that again in our next sentence. Jane was half as old as Tim will be when. So we got another when down here. And we got when Jane, this is a different when. This is the same as that x3 down here. So on our left side, we're just going to have j plus x sub 3 down here. And the right side is going to be when Jane was half as old as Tim will be when. So we've got this when in white here. So half as old corresponds to this half right here. And then we got Tim will be when is this t plus x sub 4. So again, introducing this new time variable. And we'll codify that in blue and go ahead and move on to our next section. When Mary will be 12 years older than Mary was when. So this first when corresponds to, is just going to be m plus x sub 4 that we just found out. This is going to be that first when here. And the next part will be 12 years older, so we're going to add 12 to how old Mary was when, which is this part right here. Mary was when. So that's going to be our next line. Codify that in blue, and moving on to the next sentence here. When Jane was a third as old as Tim will be when. So again, we're going to use this yellow when because we're linking that to this x of 5 here. That's going to be on our left. When Jane was, j plus x of 5. A third is old. Of course, that third goes out front here. As Tim will be when, it's going to be that t plus x sub 6, which in x sub 6 we're going to denote in purple here. And then we're going to link back to that x sub 6 in our next line, and this is going to be our final line. So this when Mary part is going to be just this left side like we've been doing. And we're going to link back to that same x sub 6 3 times. Of course, that's going to be here. And now this part gets a little tricky again. As old as she was when Jane was born. So say Mary is 9 and Jane is 6 right now. Well, when Jane was born, that's when j equals 0. That would be 6 years ago. So 6 years before that, m was going to equal 3, right? So m minus j, 9 minus 6 is the same as 3 minus 0. It's how old Mary was when Jane was just born. All right. So that's where we get this m minus j for this last part, which is another somewhat tricky part, or at least it's a little different. Okay, but with that, we're making some progress here because now we've got 6 different variables, x variables here, and we've got 7 equations. The good news is all of these x variables link back together. So what we're going to have to do is just kind of go back through this chain from x6 to x5 to x4, x3, x2, x1. We finally solve for x1, we'll finally get in our final equation. So we're going to kind of work our way back from x6 and finally get back to solve for x1 and figure out what this equation is. And the good news is the equation is actually not that bad considering all these equations are going into it. The problem was designed so that the math kind of works out, things kind of cancel out, and this final equation actually isn't any worse than the first two for the first 2 paragraphs, it turns out. So that's the good news. The bad news is we're going to be doing a lot of algebra to get back to that. So let's go ahead and hit that. So here are the equations we're going to work with. We're going to start from here, but first let's reorganize these a little bit, move some things around, and straighten that out. And we're going to start down here with our bottom equation, m plus x sub 6. We're going to solve for x sub 6 so we can plug it back into here. Then we're going to solve for x5 and plug it back into here, solve for x4, plug it into here, solve for x3. So you see what we're doing, and there's going to be a couple steps involved, but nothing too crazy. We're just going to work through the algebra. So we're going to start with this equation again, and if we just subtract m from each side, we'll find that we can solve for x sub 6, which we eventually want to plug in for here. So subtracting m from each side, we get this equation. Now we can simplify this a little bit because you see there's an m here and then there's an m over here. But first let's just distribute this 3 to the m and distribute it to the j. So we get 3m minus 3j minus m, and now we can combine these m's together. So 3m minus m is just going to give me 2m, and now we've got an equation for x sub 6. So we can take this section here and go ahead and plug that right in for our x sub 6 here. And so let's move this equation. We'll move this equation up now, and we can get rid of that other one, And this is going to be our equation for x sub 5, because we also subtracted j from it, which is our minus j over here. And now we take this x sub 6 value, plug it in, and we get this. And the next thing we're going to want to do is just multiply through this 1/3 to each of these. And doing that, we're left with this, and you notice we got two j's out here, so we can simplify that a bit. But before we do, let's clear all this out a little bit. So this minus j just becomes minus 2j, as shown here. And now we finally got an equation for x sub 5. So having discovered x sub 5, we can move this equation up next and plug in that value for x sub 5 right here. So here's our equation for x sub 4. Of course, we just subtracted m from each side to get that. And we got our minus m over here. And now we got to plug in this x sub 5 value for x sub 5 here. But before we do that, you can see we got a minus m here and a plus m here. And these are just going to cancel out. So let's simplify this a bit. Nicely cancel out. It makes it a little easier. Okay, so now, again, we're just going to take this x sub 5 value and plug it in here. And doing so, we end up with our formula here, which first thing we can do is just take these parentheses off because it's just an addition. And it looks like this is about as simplified as we can get for x sub 4. So before we move on, we can go ahead and delete all these, and now we can go ahead and take this, move this equation here over. So here's our equation moved over here, and again we're just going to sub in this x4 value here, plug that right into here, and we're going to get something that's a bit long and cumbersome, but it's not too bad. You notice we've got some t's here, we got some j's here, some j's here, and these will simplify a little bit. The first thing we're going to do is just get rid of these parentheses because it's just a plus over here, so we don't really need the parentheses. So let's get rid of those. And now let's get rid of some of these other equations we're not going to need anymore, and work this one back up. First step we're going to want to do is distribute this 1/2, so we'll apply that to each term here. Half to that, and a half to that. If we do that, we end up with this. And now we can just add these t terms here, add these j terms here, or subtract them, if you will. And we can get rid of this equation here because it has served its purpose. And moving on, combine those t terms. This t term, of course, give you this one. These two j terms give you this minus 2j. And we're making progress here. And it looks like that's about as simple as we can get for x sub 3. So I think we're about ready to take our next equation here and move it on over and plug in x3. So let's move this equation up. And now that we got this equation over here, we can go ahead and we can go ahead and clean these out just to make some space here. And now, as typical, we're going to go ahead and take this x sub 3 value we just solved for and plug it in for x sub 3 here. And in doing that, we end up with this long equation for x sub 2. It's getting these equations are getting bigger, right? Because we keep adding more and more into them. But as you can see here, it's going to simplify a bit because we got the j's that are going to cancel out. We got some m's here that are going to cancel out. So this will simplify a little bit. First thing we can do though is we can get rid of these parentheses here, which are not helpful to us. So we'll do that and clean out some of these equations here, and we'll go ahead and move up from here. So again, we can combine these m's, this m here and this m here. We can combine this 5 and this 6 here, and combining those, we'll end up with this. And lastly, we're just going to want to subtract this j from our minus 2. But before we do that, we want to distribute the 3 into here. So let's distribute that. to each one of these. And that's going to be kind of nice because it's going to cancel out with this 3 here and this 3 here. So we don't have to deal with the fractions now. So doing that, we end up with this, and now these 6j's and this minus j become easy to deal with. That's just going to be minus 7j. So move it up here, and we've got an equation for x sub 2. So having found that, we can go ahead and move on to almost our last equation here. We're getting close. Let's go ahead and pull this one up. And let's go ahead and get rid of these equations here. And now that we've pulled this equation over, its usefulness has expired. So we can go ahead and get rid of that and clean up our space a little bit. And as usual, we're going to take this x sub 2 equation, plug it in up here. And having done that, we end up with this equation. And we got a lot of terms here. But first thing we want to do is let's just go ahead and get rid of these parentheses. We're going to need these. Don't need that, because we just got the plus out front. So get rid of that parentheses, and now we're left with several terms that are going to cancel out a bit. So the 3 and the minus 3 here, we got the plus t and the plus 2t, we got the plus 4m and the minus m out here. So we got a lot we can simplify here. So we'll move on to our next step, simplify all that, and we're left with x1 equals 3t plus 3m minus 7j. And that's about as simple as we can get for x1. So let's go ahead and clear all this stuff out here. And let's go ahead and work our way up. And now we're getting close, folks. We're getting there. Last equation here. So let's bring this on down and we'll sub in for x sub 1. So again, we're going to take this x sub 1 value. We're going to sub it in up here. And when we do that, this gets it a little bit trickier because we can't just cross out these parentheses again because we got a minus out front, so that just kind of flips each of these signs. So it's going to be minus 3t minus 3m plus 7j when we distribute that minus sign. So let's do that. And from there, we are pretty close, except for you can see there's a minus 3t here and a t there. So what we can do is just go ahead and plus 3t to each side. So let's do. And having done that, we can move on to our final equation. Yes, folks, we have finally arrived at our equation. So let's go ahead and summarize where we've been to get here and what we got to do next. So we started off with these 3 different paragraphs. In first video, we took a look at this top paragraph, and we found that reduced to this equation. Second video, we took a look at this paragraph, and we found we could reduce it to this equation. And what we just did here in this video is took this beast of a paragraph here, and with a little bit of trouble and a lot of algebra, we converted it to this equation here. So what we have here now is 3 equations. 1, 2, 3 equations, and we got 3 unknowns because we got t, we've got j, and we've got m. So we got 3 equations, 3 unknowns. That means that we can work through these 3 equations to solve for each of these variables, t, j, and m, and that's what we'll do in our 4th and final video.